So my title is very simple. Which AI are we talking about? Right? So I'll do a little bit of interactive session here. Little bit of my background. Right now I come from the energy industry. I spent a couple of years before coming to a corporate world in academics, in quantum chemistry, quantum physics, biophysics, etc. And then worked in one of the biggest internet company called AOL, right? That's why we all are here on internet, right? Otherwise, there would be no internet for us. And luckily, that's where I learned how to really leverage algorithms, because at that time there were no libraries. Today, everybody can talk about AI, can talk about neural networks, right? But in the late 90s, early 2000, there were not enough libraries that you can download. Everything has to be coded. And at that time, fancy languages like Python didn't exist. Most of that was done in Perl, and there was a language called Tickle. I don't know how many of you know that one. TCL. The AOL server was actually written in that language. That was a web server before Netscape and IE browser came, right? But that's where actually one of the biggest amount of data that was there, and question was, how do I make money out of data? Monetization of data was the key, right? One is a subscription, everybody knows how that is the money, but how do I keep that subscription going and people actually will pay for advertisements? And that's where you have to build a lot of algorithms. And this is something what you see now people are talking about. And then as a result, learned a lot of things in the process, that the focus should always be money, right? If you are in business, right? And that's what I teach my students. I am an adjunct faculty at a couple of places in US and India. And then as well, advise some startups in different areas. One is in agriculture tech, one is in biotech, and others. So I bring some of that experience together for the energy industry. So there's lots of waves of artificial intelligence that have been created over the years, right? In the 50s, everybody knew about it. Then 70s, there were a lot of articles. And then late 70s, people said AI doesn't work, right? Then came time in the 2000s, people said neural networks, neural networks, neural networks, and now suddenly deep learning came, right? And then the last 3 months has been gone crazy with new term called generative AI, right? But the thing is that really defining things? People have been using, especially in the energy sector, I can tell you, people have been using these algorithms of neural network forever. The question is, what has changed for these industries, right? It's not fancy algorithm that has changed. It is the actual compute power that has changed. Neural networks have been very powerful for various analysis. And if data sizes are important for some of you, then energy industries can actually generate petabytes of data, especially in the exploration area when they are trying to figure out whether under this stage there is oil or not, right? So there is a difference. First it's two-dimensional data, then three-dimensional data, then four-dimensional data. And once you analyze that data, it can go from few megabytes to gigabytes to terabytes to petabytes. This is called data in motion, right? This is not the data of e-commerce that we are talking about, which can be also petabytes for banking industry, for example, right? But this is the data which is scientific data that is being generated. And hence, in order to analyze such data, visualize the data, to make sense out of it, you have to use algorithms, because humanly not possible, right? So, but the thing is, how do then we make money? Where what can we do? So with all this algorithms, what we can do is either optimize my workflows or automate my workflows or innovate a new solution. That's the whole game of AI or data science for industries, right? Either optimize, automate, or innovate. So you can never fail if you actually, your focus remains one of those things. And as a result, so there could be waves of artificial intelligence, but always the focus is those three things. But over the years, it has become complex, confusing, and then people actually say, oh, this doesn't work, it has never worked. But the thing is, we all know that a lot of capital waste has taken place in many industries because people don't really think how to focus on what we should really do with algorithms, right? So I come up with a term, I call it tiers go. These are the, AI actually created a lot of tiers for a lot of people. I think our lead speaker just before for Maybank was talking about that they brought leaders to learn about Perl and R and Python so that they can actually let their organization grow. One of the things, not only energy industry, manufacturing, healthcare, usually it is mostly the people below the leaders who actually do most of the work. Leaders just say, give us the result. So in energy industry, they will say, oh, I can give you the data. Can you give us results in 6 weeks from data science? So my question to them is, I will give you the results in 6 weeks if you agree to sign the contract in 6 weeks. Paperwork, right? Doesn't happen that easily in these industries, but they are expecting that 60 years of data you can analyze in 6 weeks. So this is where I think the Maybank example were very classic, that you have to educate the leaders as well. If not, what happens is what is called the capital waste. Significant in energy industry, if you read articles over the years, they have been saying that for last 20 years, there has been a significant capital waste. The data exists, but not analyzing causes a lot of problems. So in order to do that, how do we actually do these kind of things, whether it is a traditional AI, whether it's explainable AI, etc., right? All these terms are there, and how do we actually take path forward? So if I I'll ask the question, how many of you have actually made money or increased revenues using AI algorithms for your business? Just 2 hands gone so far. 3. Have you made more than $5 million a year? There 1. 1 million? Okay, good. Okay, how many of you have actually saved money for the company? Forget about the revenues. Using algorithms. 1 hand. 2, 3. How much? 5 million have you saved per year? 1 hand. What about if I tell you that in energy company we can actually save $200 million minimum by just mining unstructured data? Right? That's a lot more actually. So the question is, now those who have actually made money or saved, which algorithm did you use? Traditional AI, explainable AI, all those terms, augmented AI, traditional. Anybody else? Traditional, right? Anybody has used resilient AI, scalable AI? So why are these terms exist? What is explainable AI? Right, if I have an algorithm, if I can't explain, that's of no use. So why create one more buzzword? Right? See, the thing is, and that is what causes problem, not for, I would say, technical people, but for the leadership. They read these fancy articles in fancy magazines, and then it becomes the talk of the town saying, oh, we have to do explainable AI. Or no, we have to really now jump on the ship with generative AI. And that's how you waste money. Right? 10 years ago, I was doing some consulting for big data, and there was an article in one of the nice magazines called Big Data is Hadoop. So I met some few Fortune 50 companies, CMOs, and they would say, oh, Dr. Satyam, can we get Hadoop? I said, for what? We want to move our data warehouse to Hadoop. Think of it, logic. Why? Because the CIO has to checkbox big data. That's how we are. Like, these terms are there, they have meaning, but they need to be really used correctly. So we did a survey. If I asked which of these things you have used, most of us already said traditional AI. So these terms mean nothing, that means. So let's look at it from an example point of view, right? So this is Artificial intelligence is very simple, but it's complex for understanding and confusing. But if you think of it, artificial intelligence, simple definition, all my undergraduates will tell you is nothing but mimicking human intelligence. And by definition, human intelligence is all adaptive, explainable, right? Scalable, right? It's real time, we learn, right? If we get hit by something we don't want to hit again, so we run real time. So that's what it is. So artificial intelligence is mimicking human intelligence. It's not a different branch of things. So all undergraduate students understand it, but as we go up in the corporate leadership, we start forgetting it, right? So I'll take a classic example. This is a first business part, $200 million saving by just reducing the wasted time 2%. So 1% is 100 million. And this can come out not from structured data, not from operational data, purely from unstructured data from 16,000 PDF files in one energy company. And that too only 5% of the data from that file or PDF file. Right? Now, if you connect this data to operational data and then real time, you can actually save a lot more. But in this process, what you do, you learn from historical data, you start building your models, right? I do not want to waste my time trying to label all the data in 16,000 PDF files. I will do it for a little amount of it, use algorithms to label the rest of the data, right? Then that's how we scale. Then we validate with engineers, because this is engineering and science and engineering industry. It is not that you can just do things without it. When you validate, then you can check for whether they are field-ready terms or not. And then you can actually deploy it. And once you deploy it, you still want to make these models to be self-learning. And right, one of the terms that goes around is called AutoML. Right? As new data comes in, the model should learn itself, right? That was the whole concept of AI when the original definition came, the computers will learn by themselves, right? And eventually, we can build some prescriptive models. This is why I purposely put eventually, because at least in our industry, the risks are very higher. We do not want to deploy models that the model can make the full decision. Human cognition is very important because our risks are much, much higher than breaking an e-commerce site. So if you look at it just in the simple example of analyzing unstructured data in PDF files to save money where the time has been wasted, right? All aspects of the AI are here, right? Traditional methods from supervised to unsupervised to reinforcement learning all have to be employed at different parts, what you call phase of this modeling process. You have to understand those terms in terms of engineering. Why is the loss? What is causing the loss, right? Then you have to really understand that these terms are coming part of workflow, because any process that we do is part of a workflow. And then how do I connect it in real-time operations? And then, of course, you start from doing it from a single operations to a field operation, so it becomes really scalable, right? And the goal is after that, you understand that now my data which I labeled during my early stage of learning of modeling, I need to actually generate smart data going forward, so I don't have to do the labeling again, right? So going forward, after the model is done, after we have learned, the new data that we should collect from the field should be automatically labeled. That is what the smart data means, right? And if we can connect that smart data, then my self-learning models will work faster and more reliable, right? And then you can actually figure out, and then you can deploy these models everywhere, right? So in this sense, you can see a simple analysis of unstructured data. You have all aspects of all these crazy terms that are floating in the space. And this is how because if you keep your value proposition right, then you can do that. Now, there are some examples, right? You can actually do these things simple. Equipment failure, predictive maintenance of equipment, that problem exists across the industry. right? So all aspects of AI can be there. Complex workflows, multi-step workflows actually require innovative solutions, and that can use all these technical terms that are existing, right? But more point is that these models, any aspect of AI is to change the business. This is what is called a strategic inflection point in a business. I think thankfully my speaker before me was a really good example she put for Maybank. And this is a shift in how you do business, that everything has to be humanized, right, in their case. And that requires implementing these things using the right kind of mix, right? And from the mix, the term is, nowadays we all called about energy transition, right? And that itself is a challenge. I don't know if you read the recent story that 2 days back came out that Massachusetts, which was supposed to deploy a lot of wind farms, suddenly all those operators are like backing out. So there was a hype that, oh, renewable energy. Now suddenly they're backing out because it's not cost effective, right? So big wind farm companies are pulling out. So what will happen to energy transition now? Now why I put that term? Because this becomes very complex for energy companies. One is, of course, a drilling process, geothermal. Now, when we are looking at an energy company, all these models have to really work in concert, because from generation to consumer, we have to really understand it. So it becomes very complex. It becomes multi-step, multi-dimensional problem. But we can go further. This methodology you can apply to pretty much every other industry. Through my consulting experience in different areas, the aspects of reliable AI algorithms or scalable, you can actually take to agriculture, you can take to health, or you can take to fintech or any other industry. So, but look at the practical aspect. Is that really being applied? All of you know what happened in June, July, August with the flight cancellations. Don't they have the data? Right? But what is the application of it, right? People were stranded on airports. They didn't have cars to give them. They didn't have baby seats to give out to people. The luggages were stolen. Like, in fact, I was at the New York airport, and they said, if you have not received your luggage, wait for 48 hours before you inquire. So what happened to all that scanned data of baggages? And now people are putting their air tags in the baggages and find the bag is in different city than what airline claims. So this is the problem when you don't actually apply the algorithms right? So AI doesn't fail, it is the people that they fail. But since we are talking a lot about generative AI, there is this website that you can actually go and look at what different generative AI methods are giving you the answers, right? I'm not going to go in details of it, but this is very interesting because you can look at all of them together. So don't get carried away. AI algorithms provide power to make decisions faster for the value creation, right? If you focus on the right challenge with the right talent, right? And talent does not mean technical people. It includes the whole stack up to the leadership. Thanks. If any questions, you can reach.